Chapter 11 deals with how do you get new software applications for your organization? Do you develop them yourselves? Do you buy them from a vendor? And some of the issues around that. Now, for many of you, you'll never be involved in determining what applications are used in your organization. So, this is really just information to let you know how it works in general. And if you ever are involved in a procurement process or if you're part of a team looking at new software, this can be something that you refer back to. So there's a few things I'll highlight on this. So like any project, you really, and what we're going to talk about really here is project management skills that could be applied to anything, not just software development implementations. You have to plan, you analyze options, you come up with a design, then you actually implement it. But then number five is really important, as we saw in the failed ERP implementations. Testing is critical. And then how you implement it, we'll look at some different ways that you can actually implement it. And then not to forget that just because you got this really nifty new, excuse me, um, piece of software, it doesn't stop there. There's ongoing maintenance required for that product. So in the planning, the first thing you have to do is to assess the business need. What is it that you're trying to solve? And then a key thing in business is looking at the return on investment. If we invest this amount of money, what does it get us? How quickly do we see those savings materialize so that we paid for that investment? Businesses do not invest money just for the fun of it. You have to show that it benefits the organization long term financially. And depending upon your organization, you may need to recover that initial investment in as short as 2 or 3 years' time. Some organizations with capital equipment, it might be 5 or 6 years. But the key is you have to always be looking at what are we getting for our money? Does it give us a competitive advantage? Or does it address a possible threat, a risk to our business, our organization? So there may be that as well. Then you have to do a feasibility study. Okay, it's great that you've got this business need, but is it even practical to address it? Are there software packages out there that can do what you need to do? And one of the tools used in the analysis process, as we move into that, we think we've got a reasonable investment and there are solutions out there, but now how do you pick the one that you want, make sure it addresses your needs? One of the things that's used a lot is something called a process diagram. And it looks like this. You may have seen them. So you map out the process. In this case, the customer goes to the website. Is it a new account? Yes or no? And once you map out a complex situation like this, it can help you identify two things. One, where are the problems? And two, where are the opportunities for consolidation or an improvement? Process diagrams, flow diagrams, they go by a number of different names, are very helpful. And fortunately, there's some nifty tools that help you create these diagrams. And then once you have from this process diagram, you've defined your requirements. And now the question becomes, should you build this yourself with your own internal staff, or should you buy an off-the-shelf program? The next step in that process is actually developing the software itself, the application. And a key thing here, there's some key elements listed here. One is version control. You need to make sure you have well documented and the different versions that you're evaluating it. You need to track what's going on with your project. And we'll look at some examples of that a little later. And that includes identifying issues and then tracking the resolution of the issues. And then, of course, there needs to be some sort of review done of the code to make sure that it's following good practices. Now, this, of course, applies to if you're developing it in-house. If you're taking something off the shelf, it's a little different. But now, number 5, the one I mentioned was so critical. Let's talk about that, testing. So one of the things is what's called unit testing. And this is where you break up the major project into smaller little modules that can function independently. So you can check and analyze, does that module do what it's supposed to? Here are the inputs that module gets. Here's what the output should be. That's a lot easier to troubleshoot problems than when you're trying to put something in the entire system and the output isn't what you expected. Well, where did it go wrong? By breaking it down into individual modules and testing those individually in the development stage, you can eliminate a lot of your problems. But then at some point, you have to test the whole system. And the key here is don't rely on just your IT staff to test the functionality. Get the end users involved in this. And what I did when I implemented a new system for Tyco Electronics, who's a multi-billion-dollar company, I put together a team of testers from throughout the organization. And I gave them a challenge. I offered a reward and said, break it. Find something that doesn't work. Everybody that finds a problem gets a reward. And so I encouraged them to do wild things like on an input screen that's expecting numbers, type in letters, something that wants a percentage from 0 to 100%, type in 120%. Intentionally try and put in something that the programmer wasn't necessarily expecting, and to see how the system handles it. What that shows is, do you have error checking built into the system that will prevent a user from accidentally crashing the system? And then another concept is this idea of stress testing. And this is where your IT department can simulate a maximum load situation. What happens when 100 users are trying to input data all at the same time? Can the system handle it? In at least one of the failed ERP implementations, I believe it was the power company, it got overloaded due to a hurricane came through and knocked power out. And so the inputs coming into the system were far greater than normal. And the system just couldn't handle that many requests coming in because they had not adequately simulated stress testing. Parallel testing is one I really like. This is where you have the new system running and the old system running at the same time. Sometimes you may even have to duplicate the hardware to have two complete systems. Depending on your system, you may be able to have both programs running on the same hardware. But you've got both systems running, they're both accessing the same database, and then you put inputs into both of them and you see, do I get the same results on the new system as I did from the old system? Of course, that's assuming that the old system was working correctly. And then there's other things that you need to be aware of when you're doing the testing, making sure that the system interfaces with other software components that it has to interconnect with. Oftentimes, there are other databases, and maybe even external databases that your program has to interface with. And then lastly, it's you get the end users to do the final testing and to determine whether or not it's doing what the it was specified to do. It was set out to do. So you give the end users that final say. They're doing the report. They come back and say, I found these problems, or no, it's working fine. Okay. Implementation. We've done thorough testing, but there still can be problems when it comes to implementation that can cause some of the ERP failures that we saw earlier in the course. What I like is a parallel launch. You can launch the new system, but you've still got the old system running. It's available. So if something goes wrong, you find out, oh my gosh, it isn't working this, you can easily flip the switch back to the old system while you fix the new one. So it's not an all or nothing. You've got both and going there. That's great. Another approach is if you were able to break up the system into individual modules to where you could launch individual modules in a staggered mode instead of doing it all at once. That can really minimize any impact to the organization if something doesn't work right. That's not always possible. Depends on how interrelated things are, and if you've made structural changes to how data flows, you may have to do an all or nothing. Now, the direct is one I don't like, and that's where you just unplug the old system one day and you plug in the new one. The danger there is the new one doesn't work right, and then your entire company is down. And so that's the most risky when you just either or flip the switch. That's why I said I really like the parallel version where you can have both of them running, and you can even, with software tools, you can do it's called what's an A/B switch, where the user will be directed either to the old system or to the new system at random to see how things are working. So there are ways that you can have both systems actually working at the same time. Now, as I mentioned at the start, we have to remember that just because it's working great today doesn't mean we're done. There's ongoing maintenances. There will be bugs that show up that nobody thought about. Some new thing comes in, a vendor has a part number that is 30 characters long, and you only anticipated the maximum part number of 24. So there can be some unanticipated things that come on and say, okay, you got to fix the bug. There can also be change requests. The director of manufacturing says, I'd really like it if I could have a report that did this. So you may have to address those. The other thing is that hardware, goes bad. Hardware ages. You may have to be replacing and updating physical equipment. And then I like what the author had here, the aging of human capital. People retire. You bring on a new employee, and the system is confusing to the new employee because they don't have 30 years of knowledge with the business. And so you may have to, based on feedback from the new employees, you may have to make some changes to some of the user screens. Okay, I'm not going to go into detail on these, but just to be aware, you'll hear terms in the software development, either waterfall, iterative, or agile. They're just different ways of accomplishing software coding and implementation. And depending upon your particular project, one of those may make more sense than others. If you need to know more detail on what they are, you just do a Google search on it. It'll give you a big definition of the differences and what are the pros and cons for each. Like I said, for the purpose of this course, just be aware of the terms. Okay, so what if we decide to buy instead of develop it ourselves? There's pros and cons to both approaches. Certainly, if we buy it off the shelf, the costs may be higher, but actually, when you consider all the time it takes to create your own code and to test it and everything else, you may find that buying an off the shelf product makes more sense. The key there is not to overly try and customize it. As we saw with some of the failed ERP implementations, it was because rather than change the business processes, they wanted to change the new ERP system to match the current business processes. The more changes you make with an off the shelf software, the more expensive it becomes. So this, I like that the author showed this. What this is called, the term, and you'll hear this referred to as a weighted decision matrix. And the idea is that you come up with some key parameters when you're evaluating multiple choices, but not each parameter has the same value or significance. So this top number that says weight, you'll see the column that says matches requirements. Well, that's pretty important. That's 30% of the score, the grade for the different options. The number of years that this vendor has in this industry, their experience. Well, that's also pretty important. We'll give it a 20%. It's not quite as important as matching requirements, but certainly is there. Vendor references, yeah, you don't want to, you want to check and see have others had good success. That's important, but maybe it's only 10%. And likewise, then you get the cost at the end is pretty important, 20%. And the key is that of all the across the top there, it has to total up to 100%. Now you take each of the three, actually four options we have here, and we're going to grade each of those options for each of these five parameters up here: characteristics, attributes, and on a scale from 1 to 5. I recommend not going more than 1 to 5. 1 to 10, there's it gets too hard when somebody's evaluating. Well, is that a 5 or maybe it's a 6? Well, what's the difference between a 7 and an 8? 1 to 5 is pretty good. 1 to 3 is not enough. It's not, doesn't give you enough definition, but 1 to 5 is a pretty good thing. Most people can pretty easily do that. So we're going to say commercial software vendor 1. Do they match to the requirements that we need? Yes, they get a 5. Do they have experience? Pretty good, average, I would say. So they get a 3. Vendor references, well, we checked with 6 different, past customers, and a couple of them had some, negative things to say. So maybe they only get a 2, and the cost, wow, they were the most expensive. So they only get a 1. So you multiply the weight by the rating and add them all together. So that total score of 2.7 is 5 times 0.3 plus 3 times 0.2 plus 2 times 0.1 plus 1 times 0.2 plus 1 times 0.2 comes up to 2.7. That's the total. Then you repeat the process for the other 4. And what you'll notice is the highest score on the totals is the last option. Now, what's interesting about that is that you'll see that in terms of matching the requirements, were not the highest score. They only got a 4, but they scored higher in the other areas. And so using this simple matrix, it can say you might want to consider that option, the SaaS, as the better option compared to the commercial software vendor 1 or 2 because it's got a higher score. You can use this tool to make decisions in your personal life. You could look at, apartment 1, 2, and 3, college, college in Oregon, college in Washington, college in Pennsylvania, and have a number of requirements up there, the cost, the distance to home, all kinds of things. And you can use this tool to help you take some of the emotion out of the decision-making process. Okay, adaptation and customization, as I said a little earlier, your best chance of success is for the organization to adapt to the new system and the process flow in it, rather than to try and customize the new application to match and adapt to your current business process flow. Limit the number of customization requests you make on the new system as much as possible. Rather, take a look at what the software company has determined is an efficient business process flow, and see if you can't align your organization to match to that. That's your best chance of success. Now, the human element comes into the fact that this is going to be something that probably affects multiple departments within your company. So you're going to need to have a cross-functional team in order to really make that work. So that you need to define carefully who those people are and what departments are represented to make sure you get adequate inputs and understanding. And at least one of the ERP failures, one of the key things that happened was it was not really fully supported by senior management. And so it's really important that you have buy-in from senior management. Okay, that's a really quick overview of development of new systems, a little bit of project management in there.